Hey, welcome back to Math with Patrick and Quill. Today is August 2nd, and we're solving problem number 214 from the Daily Epsilon calendar. And we're trying to figure out why the answer is supposed to be 2 today, because that matches today's date. So it looks like we have some kind of arithmetic problem with a lot of square roots. I see the square root of 6 plus root 20, and then minus the square root of 6 minus root 20. And usually the best thing to do to undo square roots is just to square it. So that's what I'm going to do. I'm going to take our number here and square it and see what happens. If this number is 2, which it should be today to match today's date, then ultimately when I do all these calculations, I'm hoping for the number 4. So let's see what happens. Okay, so when I do something minus another thing and square it, first I need to multiply the first times the first. And the square root of something times the same square root of something is always going to give you just whatever that something is. So when I do the first times the first, I am just going to get 6 plus root 20. I'm essentially just releasing this square root sign. Then I should also do this times that and do twice that. So minus 2, and then I'm multiplying both of these square root expressions together. And there is a rule out there where if you have two square root expressions, you are totally allowed to shove them together as long as they're being multiplied or divided. So here, since I'm multiplying these two terms, I will just multiply them both on the inside of this square root sign. 6 plus root 20, and then 6 minus root 20. And then to finish this distribution of my binomial squared, I want to do my last term times itself. And kind of just like the first term here, if I'm squaring something with a square root, I'm just going to get whatever is underneath that square root sign. So 6 minus root 20. All right. I see that a plus root 20 and a minus root 20 cancel each other out, so I can ignore these. I will combine my 6 and my plus 6, so I'll get 12 at the front. And I still have minus 2 and then the square root of whatever this product is. So, anytime that you have something of the form like a plus b and then a minus b, you're going to get a squared minus b squared. If you do all the distribution, essentially your ab and your negative ab, those terms, when the inside terms and the outside terms, those cancel out. So you do just get a squared minus b squared. So to multiply this, I'll get a squared, which is 6 squared or 36. And then I'll get root 20 squared. There is just the one negative sign, which is why it's minus 20. And we could simplify what's underneath the square root sign. 36 minus 20 is 16. We could simplify our square root. The square root of 16 is 4. Order of operations says to do the multiplication before we do the subtraction, and then finally we get subtraction. So we get 4 after squaring this number, and so that must mean that our number here is 2, or negative 2 actually, because if we do negative 2 squared, then we would still get 4. Though I think I can rule out the possibility of this number being negative 2, because I know that square roots never return negative numbers. Like, it's impossible to do like square root of x and get like a negative number out of it. So I know that these are both, these are both positive numbers. So I have a difference of positive numbers. And so still I might have a negative 2 here, but then it's pretty clear to me that this number on the left side is greater than the one on the right. So I'm very confident that I do have the number positive 2 right here after squaring it. Okay, so just to say that I got 2 as my final answer, what we could do is just pop a square root over the top of all of this. And so basically everything that we were doing just had a square root sign over the top. And then finally the square root of 4 is 2. And I'm done. Okay, so that's my solution. Hope you enjoyed, and I'll see you tomorrow. Bye.